Welcome to this McAfee Center Stage webinar, What's New in Network Security, a look at NSP 10.1 and the NS-9500. My name is Jeff and I will be your host today. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact McAfee Technical Support. Our presenter today is Master Technical Support Engineer Matt Ziff. Matt has been with McAfee for 14 years now and currently supports NSP and ATD. Matt also has a bachelor's in computer science. Ladies and gentlemen, Matt Ziff.
Hi, and welcome to the presentation today. I'm Matt Ziff. I'm here to talk to you about what's new in NSP 10.1 and our new NS-9500 model sensors. I'll be covering a couple of new features, the new product registration process, and the details on the new NS-9500 models and how they stack together. Product registration is something we have recently added so we can get more accurate telemetry from the manager. What happens is when you upgrade to 10.1 or the latest versions of 9.1 and 9.2, there is a prompt after installation to enter a registration key. You get this registration key from the download site by logging in with your grant number and email. And when you put this registration key into the manager, it connects to our servers and lets us know a few various options that are in the telemetry features. If you don't register, the system locks down the automatic updating options for signature set, callback detectors, and device software and GAM through the manager. And since this process requires an internet connection, it's only really useful if you have an internet connection in the first place. If you're doing this in a dark site with no internet connection, registration is not needed. You can see whether or not the manager is registered in the manager admin domain summary page. After registering, the manager will send out telemetry by default to our servers in the cloud. You can change that under admin setup telemetry. The default telemetry feed includes things like the current active manager version, manager SIGSET version, whether it's on Windows or Linux, is it a VM, central manager in use, a whole bunch of various statistics like that, so that we can get a better survey of what kind of installs are in place. There's actually a new report as well that shows you what has been sent to us in detail under the Analysis Admin Domain Event Reporting Next Generation Reports screen. The log UI in NSP 10.1 has undergone a pretty significant upgrade. In previous versions, the multiple sub-area system faults, running tasks, user activity log, and the MDR failover log were all separate subgroups in the logging screen. They've all been merged into one log user interface that mimics the attack log in existing releases. As part of this upgrade in 10.1.7.7, the log files have moved into their own subfolder, app logs, instead of being in the root app folder. Next, we'll have a video showing off how this works. So the new UI screen in NSP 10.1 shows a new theme where it's got the dark theme here with the blacks and the grays as opposed to the previous settings, and the log screen is probably one of the places that got the biggest overhauls. As you can see, the fault screen now looks a lot like the attack log screen looks, and the other logs are very similar, where you can search through the logs for whatever data, however long you've got available in the files, or do searches for various things, and it will filter it all out for you. You can even do things like group by severity to look for different data with the logs. This makes going through the manager logs a lot simpler. background tasks, formerly called running tasks. It's the same way, the same new formatting as it is with user activity logs and MDR events. All of these were previously available in the manager under a very different UI. The rest of the manager is pretty similar, just a slightly different theme. The dashboard still shows faults in the same format it used to, with the critical error counts, and if you were to have something here and click on it, it would just bring you back into the filtered faults view we were looking at previously. So if you're just looking for the summary, you can still find it on the dashboard. Analysis and policy and devices have pretty much the same options they had previously, just with a slightly different theme. Other than the new UI log, there's a new summary screen where the registration is completed, and a place over in setup for setting up GUI access control, where all of the GUI access features that have been added are merged into one area, as opposed to being all under setup individually. In this fault screen, the faults that have been acknowledged can be filtered out that way. And if a fault is cleared, like if the database were tuned, it would just be removed from the list. It doesn't show up at that point, even if you search for the time it originally happened. So just like faults worked in the past, they're just displayed differently in the new UI interface. Signature set dynamic compilation and attack priority is a new feature in 10.1 and the latest versions of 9.1 and 9.2 that you can set up under the specific sensor under setup attack compilation to limit the signatures applied to the sensor. This is important because the sensors have capacity limits on the number of signatures that can be applied, depending on the version and the model. Primarily, this is useful for M-series sensors where we can't apply the full sig set anymore. The options include all, high and medium only, and high only. The high only is primarily useful for M-series sensors running older sensor software or the oldest versions of NS-series sensors. High and medium is basically useful for sensors that are running the latest versions of code where the memory's been optimized more and lets the M-series sensors support more signatures. And the all option is available for NS-series and virtual sensors that are at the latest releases. Here we've got a breakdown chart showing which versions and models are relevant for each setting. For M-series sensors, high only is required for any sensors earlier than 9.1.3.13, and that's also relevant for the AWS versions and early virtual sensor versions in 9.2. In the medium and high options, this is relevant for early version NS-series sensors earlier than 9.2.7.26 for the IPS, virtual IPS, and earlier than 9.2.5.72 for the NS series. And at 10.1, where all of the signatures can be used with the sensors that can run that version. The M-series sensors are not supported as a 10.1 release. They are 9.1 is the last version for M-series. A new feature introduced in 10.1 is a URL reputation service using the GTI infrastructure that we have. The primary use of this feature is to scan for headers in various fields of HTTP and HTTPS to determine what URL is being visited and then check that URL against the GTI database to see if it has been noted to be malicious. This is configured under Manager, Policy, Admin Domains, Intrusion Prevention, Policy Options, Inspection Options for the GTI Reputation Services sub-URL tab. The URL reputation has some new monitoring features that go along with it. In the dashboard, there are 2 dashboards added for the top risky URLs and top endpoints using risky URLs. You can use to see a status of what is being detected by the system. URL reputation works by checking the reputation of the URLs we're able to see, either in HTTP or put together from various HTTPS and HTTP header fields as data goes through the sensor. We reconstruct the URL based on the URI, the host, the refer, some fields in the SSL header like the CN or the host name, and try to put together as close as we can, based on the data available, what the URL would be. And then that URL is checked against the database using a real-time connection to the GTI servers. As the sensor sees traffic passing through it, going out to a web server on the internet, it assembles the URLs and submits them off to GTI on the side in real time. The sensor needs an internet connection for this to work, and the sensor has to have visibility into the URLs, either by assembling them from HTTP or HTTPS. A single HTTPS request can generate multiple URL lookups. For example, if you have a refer header and a host and URI header, those could be different and generate multiple lookups. In the case where we've got multiple requests going through a single HTTP session, we can have a lot of lookups within that one HTTP session as well. When the sensor sends the URLs to GTI, we don't hold the packets at all of the sensor. The flow continues normally. When we get a response back from GTI and we determine that the reputation on it is high and that the action was set to block, at that point we could cut off the rest of the flow, and either way we'll generate an alert. Basically, if blocking is configured, the rest of the flow's packets will be dropped, and the flow will close out as normal at that point. We can have a maximum number of URLs in query to GTI, up to roughly 20% of the flow capacity of the sensor. Microsoft Office Deep File Inspection is a new feature in 10.1 where files downloaded over HTTP can be inspected. The Office version 2007 and later use an XML-based format where the actual document file is a zipped up XML file that contains images and other things that make up the full document. This zipped format can theoretically include malware files, and when deep file inspection is enabled, we open up the files, unzip them, and do a scan of all the contents looking for malware or various other signatures, just like we would with HTTP traffic going through the sensor. There are various signatures tied to this file format that show up in the regular SIGSET as part of the IPS policy. Deep file inspection is disabled by default, and it can be enabled in the inspection options policy. For it to work, HTTP response traffic scanning has to be enabled, and if you have a malware policy assigned to the same interface, you have to disable the Office file scanning in the malware engine, as that will always take precedence. The deep file inspection feature only works for DocX, PPTX, and XLSX file extensions. On NS series and virtual sensors versions 10.1 or later, it is impossible to use deep file inspection on M series sensors at all. The deep file inspection feature can add simulated bandwidth to the sensor as the previously compressed data becomes uncompressed and is then scanned as if it were uncompressed traffic in XML format passing through the sensor. If the URLs are present in the uncompressed content, those also, in theory, can get scanned for like URL reputation, but any links aren't followed. So if you download a file from a link you got in an Office document, we'll see that, but we wouldn't download that file as part of the processing. Office files can have any number of files embedded within them in the Office OpenXML format. As we extract the files within the Office file and scan them, we will not continue on and do decompression of other files within that zip. So if you open it, if the document has a document within a document within a document, we'll only get the top layer. Whether that's because it's zipped inside a zip file or if it's part of a got another zip within the Office XML. The deep file inspection will work in both inline and span modes, and it can be configured to either block or just detect, depending on the policy applied. And when an attack triggers, it will show up in the attack log just like any other IPS event, and can be configured to ignore or block in the same way as any other IPS event. The biggest difference with this is that the Office deep file inspection signatures can't be created with the custom attack editor. That's not supported at this time. The Network Security Manager in 10.1 has a new feature where we can use a CSR and self-signed, or to replace a CSR to generate a new cert to replace the self-signed certs used by the manager. Previously, this communication used a self-signed cert generated by the manager and couldn't be replaced, but now it can be replaced. For the certificate used by the manager, you can go under Manager Setup Certification and generate a CSR, then have it signed by your CA of choice to import back into the manager to replace the cert used by the manager on 8501, 8504, 8510. And this is for the manager side. The sensor side is under Devices, set up a Trust Certificate, where you can generate a CSR for the sensor side. Both of these can be replaced, but it's completely optional. There's not a large reason to do this unless you've got a certification reason or something like that to replace these certificates. But it is now an option, whereas previously it wasn't. Another new feature in NSP 10.1 is the GUI certificate subarea, where we can replace the certificate used by the manager on port 443 for communication with customer web browsers. The certificate was previously possible to replace using a command line procedure. We now have an option under Manager, Admin Domain Setup, GUI Access, GUI Certificate, where we can import a new certificate to replace the original one. The new certificate has to be in P12 format with the cert and key in one P12 file for it to import properly. After importing, the manager needs a reboot, or not a reboot, but a service restart before it can begin to work. You can also export the currently imported one or delete it from the screen. In NSP 10.1, CAC authentication can now be fully configured through the GUI. In previous versions, it was possible to set up CAC using command line commands and by manually importing certificates into a key store. but there are now options to fully configure it within the GUI under Manager, Setup, GUI Access, CAC Authentication. You can set the OCSP options or import the certificates within the 2 tabs available on the screen. HTTP response decompression has gotten an upgrade with 10.1, where we can now support deflate in addition to gzip as compressed formats. The sensor can uncompress to scan. By enabling this option, we will be able to scan more traffic as long as the sensor is running 10.1. The setting for this is in the inspection options policy under the HTTP response decompression option. And this can be configured to be inbound, outbound, or inbound and outbound policy. This does increase the amount of bandwidth the sensor has to scan because it is decompressing and then scanning the decompressed file. Chunk HTTP response decoding has also been added as a new option to decode additional HTTP traffic. This option, if you turn it on, does another kind of decoding in addition to the gzip and deflate from the other option we just talked about. Chunk is another kind of encoding format that can be seen, and this is also only available on sensors running 10.1. This is in the inspection options policy, just like the HTTP response decompression and traffic scanning options. And just like with previous options, turning this on, it increases the effective bandwidth we have to scan because we are decoding more data that would otherwise not be relevant to the scanning engines. The proxy-based SSL decryption does require a license file, and this was previously something that you imported into the manager, but it wasn't assigned to specific sensors. That was in the latest versions of 9.2. This feature was first added. In 10.1, the licenses are tied to specific sensors. Once the license is assigned to a sensor, the sensor will update, and then if that license expires, the sensor will not allow you to do any configuration updates until the setting is turned off or the new license is added. You get a 30-day automatic warning when the license is going to expire, and it shows up in the manager as a fault. For a failover repair, you need to make sure that both devices are licensed to use the feature. The biggest reason to use the proxy-based SSL decryption is that it supports TLS 1.3 and various cipher suites that were previously not supported with the post-certificate-based decryption methods or required the agent for Diffie-Hellman ciphers. In addition, the Suricata snort can now decrypt or scan both the decrypted and encrypted packets for SSL attacks. As in the previous releases, it did not support the decrypted packets. Starting with 10.1, the real-time and historical threat analyzers are completely removed from the manager. They were deprecated in 9.1, but they were still accessible in 9.1 and 9.2 by setting a flag in the EMS properties file. In 10.1, they are fully removed, and even if you put that flag into the file, the feature will not enable. The only remaining method is to use the attack log at this point. For upgrading the manager to 10.1, there's a few things I'd always recommend checking before you get started. First up, make sure you've got a all tables backup and a configuration tables backup from the NSM you're upgrading. right before you get started. If anything does go wrong with the upgrade process, having those will let you get back to where you started much more easily. It's also a good idea to see how many alerts you have stored. If you have more than 1 million alerts stored in your database, after the upgrade, you'll have to run alert migration scripts that take additional time. And you can avoid that by pruning your data down, if you can, to less than 1 million alerts so that it doesn't have to do the extra alert migration process. You can check to see how many alerts you have under Manager, Maintenance, Database Pruning, Alert Statistics, and check to see if the total count for alerts is less than 1 million, and it will be a much faster upgrade if it is. If you have much more than 1 million, it is still possible to upgrade, but afterwards you'll have to run the alert migration scripts to convert the alerts into the new format for the 10.1 manager. When planning a sensor upgrade, aside from getting the files downloaded for the sensor, you always want to make sure that the sensor policy is up to date. If there are pending changes required for the sensor, those will also try to push out with the upgrade. And sometimes a policy upgrade and a sensor software upgrade don't mix well together. So I've always found that it's best to make sure the sensors are fully up to date before you attempt to upgrade the sensor. After you push out the upgrade package to the sensor from the manager, the sensor will require a reboot before that upgrade becomes active. So make sure you've got a maintenance window available. The sensor will not reboot immediately, but it will be in a state where the next reboot will upgrade it, so you'll want to do that fairly quickly after you give the command to deploy the upgrade. Depending on what version you're upgrading from, you may have to stop at an intermediate step. We've got the list here for the manager on what versions can upgrade straight to 10.1.7.7, which is pretty much all of them except for anything earlier than 9.1.7.77. If you're extremely old versions of 8.1, you might have to go to a higher version of 8.1 before you can go to that version of 9.1. But most current releases can directly upgrade. Older releases will have to stop at 9.1.7.77 along the way. For sensors, we have roughly the same situation. Any versions older than 9.2.5.153 will need to stop at 9.2.5.153. For 9.1, it's a little bit more complicated because up through 9.1.5.40, the next step is 9.2.5.153, but newer than 9.1.5.56 or newer can go straight to 10.1.5.41. Anything on 8 will have to stop at 9.2 before going to 10.1. The NS-9500 is a new model that is replacing the NS-91 through 9300 sensors. It is a 1U form factor model that can go up to 30 gigabits of throughput. The single SKU for the hardware can be licensed for 10, 20, or 30 gigabits individually, or grouped with other NS-9500s to get up to 100 gigabits of throughput scanning. They use less power than the 91 through 9300 per model, and they have 100 gigabit ports as an option. All NS-9500s require a license to be deployed even at the base 10 gigabit settings. After importing them into the manager, so the manager needs a special step to import the licenses. And as previously mentioned, proxy-based SSL decryption is now an option with the 9500s when they are not in a stack. The NS-9500 in the back just has the 2 spots for removable power supplies, management port, and the response port. And the front panel has the stereo console, the 2 100 gigabit QSFP ports, and then 2 free module slots that can be used for any of the NS series modules. and 4 built-in 10 gigabit copper built-in fail-open ports. Like any other NS series sensors, the modules can be added or removed to add the kinds of interfaces you need. In the case of a failover in SACS, the G1 module is dedicated to failover. After you've connected a 9500 to the manager and applied a policy with a license to it, you can see that in the status output on the sensor command line whether or not the capacity was set correctly. It's a new line in 9500s only that shows how much capacity that particular model is licensed for. You can use this to validate that it was applied correctly. NS-9500s have a new option that lets you stack multiple sensors together to scan up to 100 gigabits of traffic. Each NS-9500 comes with a direct attached copper cable that can be used for either sensor HA or for setting up the stacking option. When setting up stacking, you cable G01 of the first sensor in the stack to G02 of the second sensor, and then G01 of the second sensor to the G02 of the next sensor until you cable it all the way back into the original. You can either have 2 nodes or 4 node stacks, and the stacks are required the direct attached copper cables, so the sensors can't be very far away from each other. They're about 3 feet long, so they pretty much have to be right on top of each other in the rack. It is possible to set up stacked sensors in an HA configuration. If you do this, both stacks have to be identical to each other with the same exact modules installed in the same locations in each sensor within the stack. If you are setting this up, the G1 module slot is consumed by the failover, and G12 is unusable. If G13 and 14 are available because it's a 4-port module, those can be used. For failover, both 100 gigabit USFPs or USFP 40 plus gigabit fiber can be used to do the failover, allowing for slightly longer distances than the direct attached copper cables would allow for making the stack itself. Those are not included with the base model and have to be purchased separately. The 9500 stacks have some features limited because they're not available in the current release, basically. The SSL resumption, configure packet capture settings for span ports, inbound and outbound proxy-based SSL decryption, integration with NTBA, EIA, sensor configuration, import-export, DOS management, sub-interface allocation to child domains, port clustering, and reporting are all basically disabled for NS-9500 stacks. This will probably change in the future as more features are implemented, but at the moment these are all disabled features. The port clustering one is probably the one that will be the most complicated, because if you have a port channel, for example, and you want to use a stack to scan it, it isn't possible with a single stack to scan the full port channel because the port can't be clustered together with a stack. You can do it in a stack HA because each port that's part of one sensor is in a group with the other sensor's port, but it isn't possible within a single box, as it is in current models with the port clustering option. This is available with standalone sensors. This is just stacks have disabled these features. When cabling the NS-9500 for failover, the G01 port is used for standalone NS-9500 sensors, and the G11 port is used for failover between stacks. Each module, each individual node in the stack has to have G1 filled with a module supporting failover, either the 100 gigabit or the 40 gigabit fiber modules, and then connected to the other equivalent node of the stack, so 1 to 1, 2 to 2, etc. all of them are required for a stack failover. None of the failover cables are included with the sensors, except for in the standalone case where each NS-9500 has the one direct attached copper cable included. In the case of a failure, the stack will continue to run with as much capacity as possible. So like in this example here, the second node has failed. So the stack will have a total of 75 gigabits capacity rather than the original 100. And any interface modules that were plugged into that second node will cease functioning. So if you had all of your traffic plugged into a node on the node 1 and the others were just acting as capacity increase nodes, you'd have a reduced capacity but no other impact. But if your node 1 failed and that was where the modules were, those modules would be out of line and the remaining sensors would continue to work if they also had traffic in them, but the original modules would fail. So we recommend having active fail-open kits for each of these interfaces so that the failure of a single node in the stack doesn't bring down traffic for you. If this happens, we get faults in the manager as normal for any sensor hardware errors. In the scenario where multiple nodes have failed, depending on which nodes fail, it's possible that nodes in the stack could be isolated from each other. In this scenario, in a 4-stack setup, nodes 2 and 4 have failed and stopped responding. This isolates 1 from 3, and each will continue to function as if it were a 25 gigabit node, basically, scanning as much as it can, but unable to get help from the other node member that's up. So if your traffic is all plugged into node 1, then only node 1 will be able to work on that traffic. If you had traffic plugged into nodes 1 and 3, both of them would continue to process at the reduced capacity. When NS-9500s in a failover scenario encounter a node failure, the stack checks the status of the other stack to see if it's in good health. Like in this scenario, if the active stack was the first stack on the left and it has a node failure, it will determine that the other stack is in good condition and shut its monitoring ports so that the traffic will be forced to fail over to the other sensor stack so that the traffic can be scanned at full capacity. This will make sure that as much traffic as possible can be scanned at once. In this kind of failover scenario, if the first stack has already had a problem and the traffic has moved over to the second stack, and then the second stack also has a problem, the traffic will not immediately fail back as long as the second stack only lost one node. The capacity will try to move to the stack with the highest capacity, but it won't move unless the other stack has more capacity. So in this scenario, both of them have one node out, so it won't fail over to the other node. NS-9500 sensors require a license to deploy and work properly. They can be licensed for 10, 20, or 30 gigabits for a single node, or in stacks at 40, 60, or 100 gigabit. 40 and 60 are 2 sensors. 100 gigabit is 4 sensors. The licenses for stacks can be purchased as either standalone or HA. They require a different license for both modes. And all of the licenses have to be applied before you can work with the sensor at all. At this point, that's the end of the presentation, so back to you, Jeff.
All right, thanks, Matt. Great job. We want to remind everyone we have expanded our customer self-service capabilities, including but not limited to our McAfee Enterprise Support app for Android and iOS, new product support pages, the support community, McAfee Support YouTube channel, and social media help needs on Facebook and Twitter. Also, the EPO Support Center plugin is available free of charge to download within your EPO application. You can learn more about the EPO Support Center on the McAfee Support YouTube channel and on support.com. And this will conclude today's webinar. Stay safe out there, everyone.